All right, so let's jump into this next slideshow here. So there's been a little modification on the original schedule plan in the syllabus. So the next topic was going to be generics, then collection, then metaprogramming. I moved up metaprogramming for two reasons. One is that it's going to have good synergy with the practice project right now. So quick and simple thing to add on top of the project. And two, it's going to be shorter and still allow us to have something relevant to test you on, for the first exam. So we are going to spend probably, like I said, 2, maximum 3 sessions on metaprogramming, something like that. And then we're going to have our first exam. So the exam will be focused obviously on metaprogramming, but it's not going to be the only topic. Everything that we covered in the review will be fair game, okay? It's just that what we covered so far in the review is new for some of you, but it's not supposed to be, new for this course. So the exam will be really more weighted toward metaprogramming. All right, so let's get started with our first advanced, quote-unquote, object-oriented programming technique in Java, which is metaprogramming. So here's an overview of what we are going to cover. The first thing we are going to cover, reflection. So define what is reflection, and then cover 2 specific types of operation, okay? How to retrieve a class object, which you are going to see is a key to do anything with reflection, and then how to retrieve objects that represent the members of a class. So members of a class can be fields, can be methods, can be things like that, okay, can be even like classes. So we're going to first learn to retrieve an object that describes a class, and then use that object to retrieve more objects that describe the methods and fields that populate that class. So the idea here is introspection. That's another term that you are going to read when you look up literature on metaprogramming. Introspection means the capability for your code to look at itself, okay? And intercession is the capability of your code to modify itself at runtime, which is pretty cool. The second thing we are going to talk about that is also related to metaprogramming is Java annotations. So the first topic, reflection, you have to know it exists. In the future, it might become something that is even more heavily used. Right now, this is pretty much what allows a lot of work in frameworks and stuff like that. But annotation is really, I would say, more pragmatic. Okay, so even if you never use a metaprogramming technique in your life after this course, you will use probably one form or another of annotation if you do anything at all with Java. Okay, so again, we're going to not only cover the default annotations that Java offers to you, but also look at how we can define our own annotations. And then we are going to finish by a few slides on a case study on a fancy algorithm. That fancy algorithm is going to map very nicely to your config class for the practice project. Okay, so this is where we are going to explore how to use reflection and annotation together to do handling of parameters for an algorithm very, very easily. All right, so mandatory readings. I give you again the fragments from the textbooks that are relevant to this part. Section 4.4 I would say for background only. We're not going to go really in depth in that material in the lectures. Section 4.5 is going to correspond to the first half of this lecture, which is reflection. And then chapter 11 on annotation is going to cover the second half of this lecture in more detail, actually. Okay? So this is actually your reading to-do list for this module. 2 recommended readings. And this is what the slides are based upon, okay? So the first one is a Java tutorial on the reflection API. And the second one, guess what, is a Java tutorial on the annotation, okay? If you have any question about the slides, or maybe, after listening to the lecture, you don't see exactly when you read the slide what I was talking about, this is where you want to go, okay? Those 2 tutorials are the backbone pretty much for that slide presentation we're going to go through. So let's start with the Java Reflection API. I'm going to go fast on that. Quick reminder. what is a Java object? Well, we know that we have primitive data types, okay? Boolean, byte, short, int, long, and so on and so forth. And we know that we have reference data type. So when we talk about Java object, we really talk about reference to those objects most of the time. Okay. So the one thing that is interesting about any Java object is that they all inherit from java.lang.object. So we have this idea that we have a class that represents objects. Sorry, I should have used plural there. Okay, so anything like class, enums, arrays are object. Interfaces, all of that are reference type. All of that are represented by instances of that one class, java.lang.object. So the interesting thing, and what we are going to use a lot in this module, is that we have also a class in the Java standard hierarchy that represent classes. The name is java.lang.class. Okay. As a matter of fact, for every type of object that you have in the JVM, okay, you are going to actually instantiate an immutable instance of that class. So immutable, remember, that means you cannot change it. Okay, there's no way, even by trying workarounds, to change the state of that object. So we are going to have an object which is an instance of java.lang.class that represents, for example, our class employee. That is what provides us with the ability to do anything related to metaprogramming. Okay, it has to be built in the language. So at the basic level, this object of the class, there's going to be a funny module, by the way. I keep saying class, and object, and you have to capitalize in your mind, right? So that object of the class, with an uppercase C, allows you, at the very minimum level, to create new classes and new objects. We never do it. We use the basic Java syntax, but that allows us to do it, programmatically by invoking methods and stuff like that. And it also provides us with a bunch of methods that allow us to inspect during runtime, during the execution of your code, the properties of the code itself. What classes do I have right now in my program? Okay, is this class does this class have a superclass? If yes, I can go into that superclass and examine it, analyze it. Okay, so this opens the doors to introspection and intercession. So the basics of reflection. All right, so all of this is built in Java. Let's go a little for a few slides, 6 slides or so. Let's go just over quickly the why. Okay, why do we bother even with metaprogramming? So for right now, we talk only about reflection. So what is reflection good for? Well, first item, extensibility features. That's something that you're going to get to experiment for yourself with our practice project. Okay, I want to say in my configuration file, the problem to solve is 1max. And 1max is the name of a class. So I want your code to dynamically read that string, and then from that string that says 1max, find a class and instantiate it. That's metaprogramming. The next day, if I replace 1max by, I don't know, knapsack, knapsack problem, whatever, same thing. From a string, you need to be able to find a class, and from that class, you need to be able to create instances. Okay? So that opens the door to code that is very, very extensible. Okay, you just provide more code. You say in a configuration file, well, when you start, I want you to use this class, and that class over there. You load the class if they are not already loaded. In our case, they are going to be already loaded to make things simpler, but you can even remotely load the code for the class, find the code for the class, etc. In Java 8, you can even compile the code for the class during runtime, and then you have super abilities for extensibility. Okay, that's really the key word with metaprogramming. It allows you to do things in a way that is smarter, pretty much. Second case, what is reflection good for? Every time you use an IDE, you are using actually reflection, not you directly, but your IDE. Okay, you are all familiar with the concept of a class browser. Okay. You can see the list of all the classes in your project in the left pane or something like that. You click on one, you see the list of fields and methods. Well, all of this is reflection. All of this is actually code that is capable to actually go through your code and find, what is relevant to display there. Same thing with the autocomplete feature. Okay, this is something that you can actually implement with reflection. Debuggers, same thing. Test tool is actually probably the most interesting example. A lot of testing frameworks allow you to just write a class that's named, test, and then the name of the class that you're supposed to test with it. And then your method, you have some helper method, and then you have test something. So the name of the method have a sort of convention to them, right? You're going to start them all by test. Well, something like reflections allows you to go into a class and say, well, what is the name of that class? The name of that class is test something. Well, so I know it's meant to test the class something. So I'm going to find the class something, create an instance, and I'm going to pass this instance to my testing class test something. And then I'm going to look into test something, and I'm going to find all the methods that start with the word test. And I'm going to call them. All of this is code that operates on code. Okay, you can see it even though we just describe it, in generic terms. Well, that's again the defining characteristic of metaprogramming. Now, all of this doesn't come free. So we're going to talk about 3 drawbacks, I think. The first drawback, the most important one maybe, is performance overhead. So you are going to look at your classes dynamically during runtime. That's never going to be performant. So anytime you have like a section of code that is really critical in terms of performance, if you have a choice, try to avoid metaprogramming techniques. Okay? Sometimes you don't have a choice. The nature of the work implies that you need to use metaprogramming technique, then so be it. But you have to be warned that this is actually not performant. Okay? Second drawback that we are going to talk about, exposure of internals. So this one is interesting because with metaprogramming, you can potentially do things that completely obliterate the concept of encapsulation and abstraction that we talked about previously. So the whole deal with encapsulation/abstraction is that you are able to hide things from other programmers. Well, if that other programmer is actually using the reflection techniques we're going to discuss in this class to access your classes and the object of your class, they can completely bypass the fact that a field is private. They can say, I want to see the list of fields, for that object, for that class, and then I want to access them and modify them. And you are going to see that in our code example, the code example I'm going to use at the end of the session, and when you implement those techniques in your own code for the practice project, you are going to see that there's a way to say pretty much waive the private status. Let me get in. Okay, so that's potentially very, very dangerous. So my recommendation about that would be, if you are using metaprogramming, try to encapsulate the use of metaprogramming. Try to keep it within a team. Try to keep it within one programmer scope on a project. Okay? Because if other people start to do metaprogramming on classes that have been developed from legacy code or from another team in the project, then you can really bypass all those protections. And therefore, you are reverting back to a sort of pre-OOP era, where, yes, you talk about encapsulation and abstraction, but you cannot guarantee it. The language cannot guarantee it for you. Okay? So again, for performance reason, for safety reason, you have to be careful when you decide to use metaprogramming techniques. And then the third drawback is security restriction. So it kind of, piggy rides with the previous one, but this one is more specific in the sense that there are things called security managers in Java. When you run something like an applet, which is kind of an obsolete example now because applets are being pushed out of the window there. But let's use that for an example for now. Like when you use something like an applet, you have a security context that is really restrictive by default. Okay, meaning that you cannot open files, you cannot do a bunch of things actually that you would expect to be able to do in a Java program. That's to allow to sandbox okay, those applets that you download or used to download from the internet, so that they don't, wreak havoc on your systems. Well, the problem is that to be able to do introspection, intercession, and things of that nature, to be able to do metaprogramming, you need the permission to be set appropriately, to be laxist enough that you can actually do those things. So in all those examples, like applets, etc., typically you do not have those permission. So that throws metaprogramming out of the realm of possible techniques to use in your project. Okay, so you have to be careful about that. Another thing that you have to be careful about, and we experienced that firsthand in my team actually. We were collaborating with somebody that developed the applets.org. It's an intelligent tutoring system for people who are just learning to program. That's a tool that I use actually in my introductory classes. But the person that developed applets.org wrote everything in Java, which is cool, okay? And they used actually applets at some point, and now they are switching to a different technology. But they are still using Java. But the problem is that they obfuscate their code. How many of you knows what it means to obfuscate code? Say that again?
It's like black box in.
Yeah, but it's at the bytecode level, okay? So you actually compile your code so that you generate bytecode that is difficult to reverse engineer. So that's the key with obfuscation, is a defense against reverse engineering. Reverse engineering is I make my .class files available, okay? So I don't want to give you my source code. I have this very clever algorithm that I'm really proud of, but I give you the class file, so you have the bytecode. Reverse engineering is a term that's used to designate the set of techniques that allow you from the bytecode to retrieve the algorithm, okay? And by default, I'm not saying it's easy, actually. I never tried it, so I should really shut my mouth on this. But by default, it should be relatively easy to reverse engineer. But obfuscation technology allow you to compile your code into bytecode so that it's actually made less legible. It's less easy to make that backward translation. And that messes also with metaprogramming.
It's like renaming class names and variable names that you use in the class that you cannot easily rename.
Yeah, that's the first thing I think also too when I think about obfuscation, like renaming variable name, etc. But I'm probably wrong, because there's a lot more that goes in obfuscation than that. But that's the first reflex. Okay, if you want a simplistic example, yeah, that would be changing the names of the class, putting underscores and blah blah blah, making it less human readable. But there's more. I know there's more to that game than that. I'm not just expert in that stuff, so I cannot comment more. But the bottom line is that there are all of those scenarios, like restrictive, sandbox-like permission or obfuscation, that are going to also mess with runtime operation, because that's what happened, right? When you do metaprogramming, you want to figure out, you want to get an object that represents a class. You have the class name. Well, if even the most basic obfuscation has changed the class name in the bytecode, you're not going to be able to retrieve that. So when you put 1max in that configuration file, really in your code, the class that corresponds to 1max class is not called 1max anymore. So problem to locate it with metaprogramming techniques. Okay. All right, it's 10:38. We're going to stop here for now. Like I said at the beginning of the class, I need a few minutes to upload all those videos. So I'm going to stop the recording right away. Next session, we are going to start right here with the first type of operation that we're going to perform, which is retrieving a class, uppercase C object, that's going to open the door to do all of those operations we have been discussing about.